Students, in this video, we learn about the first particular case of continuous probability distribution, and it is called as exponential distribution. It is called as exponential distribution because the function, which is the PDF in this distribution, is in terms of exponential function. Exactly. Let us consider a constant alpha greater than 0 and consider a function which we known as, it is actually e written in a different way. It looks like epsilon e of alpha comma x or e of x, which is a splitting function. So which takes the value alpha e power minus alpha x for a positive interval, that is 0 less than x less than infinity. 0 otherwise, or it can also be written as normally. So the negative intervals comes first, 0 in this interval minus infinity less than x less than 0, alpha e power minus alpha x in the positive interval 0 less than x less than infinity. And the continuous probability distribution having this function as the probability function is called as exponential distribution. Now, so let us check whether this function satisfies the two conditions, okay, which has to be satisfied by the PDF. Since exponential function is positive always, and we have taken that alpha parameter is positive, so clearly the function takes only non-negative values, and we can show that that integral alpha e power minus alpha x between 0 and infinity 1. That means this function satisfies this condition, that is, it is non-negative, and the integral minus infinity to plus infinity of that function epsilon of x is equal to 1. Okay, so if you want, you can check it. A very simple integral which I leave it for exercise. Okay, now, so it's a very simple one, and in case of problems you will be mentioned about that exponential distribution if you're given a problem on the distribution. Okay, not worry about recognizing that. Fine. Okay, now let us find out the mean and standard deviation of this distribution. We know that mean, which is denoted as mu, which is nothing but expectation of x, which is nothing but integral minus infinity to plus infinity x into that function, which is the PDF here, which is known as epsilon of x or e of x. Now, it is a splitting function, and the value of this is 0 in the negative interval, that is 5 minus infinity to 0, it is 0, and in the positive interval, namely 0 to infinity, it is alpha into e power minus alpha x. Now let us integrate this. The first integral vanishes because integrand itself is 0. Now in the second integral, I will take that constant alpha outside. Then you are getting integral 0 to infinity x e to the power of minus alpha x dx. Now, how to evaluate this integral? So very simple, because we have to use the Bernoulli's rule, a polynomial into an integrable function. Now applying the Bernoulli's rule, you get the first term as, keep that x as it is, integrate e power minus alpha x, you are getting e power minus alpha x by minus alpha, minus differentiate x, you are getting 1, and integrate e power minus alpha x by minus alpha, you are getting e power minus alpha x by minus alpha whole square. So the integration process ends there, because for the next term I have to differentiate 1 and derivative 1 is 0. Okay, now integration process ends here. Now take the limits. and we can show that the value of the first term, integrated term, is 0. Upper limit is 0 because of that e power minus alpha x. Lower limit is 0 because of x. Since alpha is positive, e power minus alpha into infinity becomes e power minus infinity, which is negative. Now, let us find the value of the second term, that is, it is equal to, so alpha into minus 1 by alpha square outside, and inside you are left with e power minus alpha x with limit 0 and infinity. This becomes minus 1 by alpha outside. Put x equals infinity, e power minus infinity, because alpha is positive, minus e to the power of 0. Now we know that this is 0 and e power 0 is 1. Therefore, getting minus 1 by alpha into minus 1, which equals 1 by alpha. That means we have got that mean mu equals 1 by alpha. Reciprocal of the constant, what is used in that PDF. Okay, now let us find out the variance. For that, first we find the expectation of x square. By definition, it is integral minus infinity to plus infinity x square into that PDF e of x dx, and which are to split into two integrals, minus infinity to 0, x square into 0 plus 0 to infinity x square into e of x dx. Now, once again the first integral vanished because the integral itself is 0. Now, second integral if we evaluate, once again we have to use the Bernoulli's rule. So, first let us substitute for that. 0 to infinity x square into epsilon of x here is alpha into e power minus alpha x dx, which can be written as alpha outside 0 to infinity x square into e power minus alpha x. Now, integrating this, we get, using the Bernoulli's rule, x square into e power minus alpha x by minus alpha minus derivative of x square is 2x into integral of e power minus alpha x by minus alpha is e power minus alpha x by minus alpha whole square plus derivative of 2x is 2, and integral of this function e power minus alpha x by minus alpha whole square is e power minus alpha x by minus alpha whole cube. Now we can show that between 0 and infinity, value of the first term and the second term is 0. Okay, once again the same the reason. So it is upper limit is 0 because of e power minus alpha x, lower limit is 0 because of x square and x. Now, taking the limit for the last term, which is alpha into minus 2 by alpha cube outside. For that e power minus alpha x, we have to take the limits between 0 and infinity, which equals to minus 2 by alpha square into e power minus infinity minus e power 0. And we know e power minus infinity is 0, it goes off. So e power 0 is 1. So this becomes 2 by alpha square. Now we want variance, sigma square equals e of x square minus mu square. What is e of x square? Which is 2 by alpha square. Mu we have got it as 1 by alpha. So mu square becomes 1 by alpha square. So this simplifies to 1 by alpha square. Therefore, standard deviation, okay, sigma equals positive square root of this, which is 1 by alpha. Now, let us go back. Now look at the mean what you have got. So which is 1 by alpha. And this sigma also we have got it as 1 by alpha. Therefore, we can say that for an exponential distribution, mean and standard deviation are same. Both are equal to the same value, reciprocal of the parameter alpha used there, which is 1 by alpha. So you may also get the question like this. Show that for an exponential distribution, both mean and standard deviations are same. Okay, very simple one, simple integral. Now we'll find out what is called the CDF of this exponential distribution. Okay, and we know that CDF is given by f of t equals integral 0 to minus infinity to t, the probability density function, which is e of x e or dx. Now since this is a splitting function, so where we have to consider two intervals, namely minus infinity to 0 and 0 to infinity. Okay, therefore let us consider t in the interval minus infinity to 0. Now for t between minus infinity and 0, f of t equals integral minus infinity to t, this function PDF, which is e of x dx, and we know that that value is 0 in that negative interval. Therefore getting minus infinity to t 0 dx, which is 0. Now for the positive interval, that is 0 less than t less than infinity, f of t equals integral minus infinity to t, so that e of x dx, which you have to split into two integrals, namely minus infinity to 0, 0 there, plus 0 to t. In that case it is alpha e power minus alpha x there. Now the first integral vanishes. Evaluating the second integral, which is a simple and straightforward one, where that alpha is a constant, take it outside. Integrating e power minus alpha x, you are getting e power minus alpha x by minus alpha between limits 0 and t. So alpha alpha cancels. So left with minus 1 in the denominator. Put x equals t, you are getting e power minus alpha t, minus put x equals 0, you are getting e power 0. And e power 0 is 1, and multiplying both numerator and denominator by minus 1 to get rid of the negative sign. So this becomes positive, this becomes negative. Therefore, you are getting 1 minus e to the power of minus alpha t. That is CDF is f of t equals 0 for minus infinity less than t less than 0, 1 minus e power minus alpha t for 0 less than t less than infinity. Now this is how we can get the CDF. Now is it possible to get PDF or probability function from the CDF? We have got CDF from the PDF. Now in the reverse direction, can we get back PDF from CDF? We can, and that process is very simple. Okay, that means the PDF p of x here, it is e of x equals f dash of t. Just instead of t, after that you replace t by x. But in simple words, differentiate and replace t by x. And derivative of 0 is 1. Sorry, 0, not 1, 0. So, and replace t by x, you are getting minus infinity less than x less than 0. Differentiate 1 minus e power minus alpha t. Derivative 1 is 0. And e power minus alpha t. E power minus alpha t into minus alpha. It limits minus infinity less than x, 0 less than x less than infinity. Now that simplifies to 0 in negative interval, and this simplifies to alpha e power minus alpha x, because we have to replace t by x. So that will give back the PDF. Okay, fine. Now you may ask to find the CDF. This is how we can find the CDF. The problems are very simple. So one problem is sufficient here. So in the problems, you always given a function which is the PDF of the exponential distribution, or you may be given that variable is exponentially distributed. Here the variable is x with the mean equals some value. Then you're asked to find certain probability values. Now if mean is given, now we require alpha to write the PDF or probability function, and we know that mu and alpha are related by this. One is reciprocal of the other. Mu equals 1 by alpha. Take the reciprocal of that mean. You are getting alpha. Then rewrite that function, and using the definition we can easily find out the what is called the required probability. Now we'll work out a problem. Okay. Now I'll take this problem. It says that in a certain town, the duration of a shower, the duration of a shower is exponentially distributed. With mean equal to 5 minutes. With mean equal to 5 minutes. Now find number 1, a shower will last for 10 minutes or more. The first case, 10 minutes or more. Second one, less than 10 minutes. And case 3, between 10 and 12 minutes. Between 10 and 12 minutes. Okay. Now, the problem is very simple and straightforward. It is clearly mentioned that this variable, which is the duration of a shower, is exponentially distributed. Okay. Now, it's given that mean is 5 minutes. That is, mu equals 5. Now we know that mu equals 1 by alpha. That is, alpha equals 1 by mu, which equals 1 by 5, which equals 0.2, or we can take 1 by 5. Suppose if 5 is 3, then I won't take the decimal equivalent because you're getting recurring decimal places. Here, since I'm getting exact value as a decimal one, so I'm taking the decimal value. Okay, instead of 5, it is 3, don't take it as 0.333, you take it as 1 by 3 only. Fine. Okay, now the PDF is E of x or E of, what is alpha here? 0.2 comma x, which equals to 0 for negative interval, alpha into e power minus alpha x, that is 0.2 into e to the power minus 0.2 x in the positive interval, 0 less than x less than infinity. Now the first case, we have to find out the probability that shower will last for 10 minutes or more. 10 minutes or more. Now, what is the notation for this? P of variable x, which denotes the duration of a shower, 10 minutes or more. That means greater than or equal to 10, which is same as P of 10 less than or equal to x less than infinity, which equals to integral 10 to infinity this function e of x, which is the PDF dx. Now this is belong to the positive interval where the value of the function is 0.2 into e power minus 0.2 x. Before substituting there and taking that 0.2 outside, which is a constant, you are getting 0.2 outside, integral 10 to infinity 0.2 into 0.2 I have taken outside. Okay, so we have only that function, namely e to the power of minus 0.2 x. Let us integrate. Very simple integral. What is the integral of an exponential function? Just that exponential function divided by coefficient of that variable x here. It is minus 0.2. Now, so the limits are 10 and infinity. Integrating, we are getting 0.2 outside, e power minus 0.2 x by minus 0.2. 0.2 cancels. We are getting minus 1 outside. So put x equals infinity. We are getting e power minus infinity. Let's put x equals 10. 0.2 into 10 is 2. So e power minus 2. So this is 0 goes off. So we are getting this thing as e to the power of minus 2 or 1 by e square. Or you can write the equivalent value calculating from the calculating, and you're getting this 0.1863. Okay, now let's consider the second case. Probability that shower will last for less than 10 minutes. What is the notation for this? P of x less than or equal to 10. Okay, less than 10 minutes. Means strictly less than 10. Okay, you can exclude that equality. And by definition, it is same as probability from minus infinity less than x less than 10, which equals integral minus infinity to 10. So e of x dx, which can be split into two integrals, namely minus infinity to 0, 0 there, plus 0 to 10, there 0.2 into e power minus 0.2 x. So integrating the second one, because the first integral vanishes, 0.2 outside. Same as the previous, e power minus 0.2 x by minus 0.2. Exactly the same as the first case, the integration part. Only thing is limits are different. Okay, so I'm getting minus 1. This and this cancels. And put x equals 10. You're getting e to the power of minus 2 minus, put x equals 0, e power 0. Take that minus inside. You are getting 1 minus e power minus 2. And we can show that it is equal to 0.8647. Next, last case is probability that shower will last between 10 and 12 minutes. This is P of 10 less than x less than 12, which is nothing but integral 10 to 12 e of x dx. And since 10 to 12 is a part of the positive interval, we can no need to divide the integral into integrals. Just take the function as 0.2 into e power minus 0.2 x, exactly the same as the previous integral, only the limits are different, 10 and 12 now. So therefore you're getting, I can directly write it. So minus 1 outside, upper limit is 12 now. You get e to the power minus 2.4 minus e to the power lower limit is 10. So you're getting e to the power of minus 2. You calculate this and you'll get it, you'll simplify this, or you can write as e to the power of minus 2 minus e to the power minus 2.4. Calculate this, and that is the required probability. That means prompts on this are very simple. We always given the mean. Finding that mean, you have to find out the knowing the mean, you have to find it alpha. Then substituting, you're writing the function. Then write the PDF and find the required. Okay, I left one problem for exercise in the notes. Try that one. That is sufficient, and work a few more problems. Okay, that completes one particular case. In the next video, I'll teach you the very important one called as normal distribution. In fact, it won't involve integral. It makes use of only normal distribution table. I'll take up that in the next video. Okay, thank you.